two-dimensional arrays are very similar to their one-dimensional cousins. The biggest difference is how we visualize them. A single-dimensional array is visualized as a contiguous list of elements. Just a singular linear list where the first element is followed by the second, is followed by the third, etc., until you get to the last element. But a two-dimensional array, it appears more like a grid, where you have rows and columns. Think of an Excel spreadsheet or a tic-tac-toe board. That is how we visualize two-dimensional arrays. In memory, interestingly enough, it's still linear. However, instead of having a rectangular block of memory as you might visualize it with a grid, it is a linear list. If you have a total of 5 elements by 10 elements, which is 50 total elements, that would indicate that you have 5 rows, 10 columns each. So in memory, it will store the first row's 10 elements, immediately followed by the next row's 10 elements, etc., until you get all 50 elements. The good news is, just like with single-dimensional arrays, finding the address in memory where each element is located is completely handled by the language itself. We don't have to do any complex address mapping to find these elements. Let's start by looking at the syntax of a two-dimensional array. This should look very familiar. It is the syntax for creating a one-dimensional array. But to make it a two-dimensional array, we have to specify within the square brackets a comma that is going to tell it now we have 2 dimensions in here. It's shorthand for showing, well, there would be values surrounding this comma, like a 3, 2. But you don't actually put it here at the time you declare the variable. It is done at the time you initialize it over here. We could start with a 10 by 10. So we know that there's going to be, in this case, 10 rows followed by 10 columns. This is known as row major order, where the row represents the first index and columns would represent the second index. If we had a non-square memory space that we wanted to work with, or grid space, we could of course specify a different number of rows or a different number of columns. Let's go ahead and do that, because if I do 10 by 10, all of the work I do later with loops and accessing the individual indices, it won't be very clear which is the row and which is the column, because they can both support the same number of elements. So let's go ahead and specify that this will be 8, the rows, and then we'll have 10 columns. Now, initializing a two-dimensional array is very similar to how you would initialize a one-dimensional array, except because now we have defined 80 possible values in this array, because 8 times 10 is 80. Clearly, if I were to show you the list of values using this syntax with the initializer list, the curly braces, it's going to get quite large. So I won't do it for a large example like this. I could, however, show it to you using a smaller example. I'll create another array called B. And again, I don't actually have to say new int. There is the shorthand syntax, which allows me just to jump right in to specifying the individual values. To do that, I can't just use a single set of curly braces. I will need to have sets of values within these curly braces. And each set will represent individual rows. So let's say I wanted my first row to have 4 elements, and they're all even numbers, the first 4 even numbers. So we'd say 2, assuming 0 is not even, 4, 6, and 8. So now what I've done is I've specified a two-dimensional array where I have one row and four columns. If I wanted to add a second row, let's put some odd numbers in this one. We'll say 1, 3, 5, and 7. This is how I would do it. Now I have two rows. The first row is this first set, and the second row is this second set. And because things are zero-based, this represents the 0 row, and this represents the 1 row, as far as indices are concerned. Then the columns are 0, 1, 2, and 3. And on the next row, we have the exact same number of columns, 0, 1, 2, and 3. So if I wanted to access this 5, I would have to go to row 0, row 1, and then column 0, 1, 2. So it would be B, row 1, column 2. And then I could say int val is equal to this, and then console write line val. We'll end with our console read line, and then I'll hit F5. As you can see, the value 5 is actually printed in our console window, as expected. Writing a value to a specific array location is the same. You just have to take this syntax and put it on the left-hand side of the equal sign. So we could take B12, and if we wanted to change this 6, now let's change a different column. Let's change the 8. That would be row 0, column 3. And I can assign that to a 10. It's still an even value, but I change it to a different one. So this is the reading portion of accessing a two-dimensional array, and this is how you write to one. Not all that different than a one-dimensional array. It's the same syntax on both sides of the equal sign, just like one-dimensional arrays, except now I have to specify two different indices instead of just one. And as long as you remember, the first index corresponds to row, and the second one corresponds to columns, you should be okay with making sure you stay within the bounds of your array. But to demonstrate that, let's go back up to A here. As a matter of fact, I could just take the B array and put it on top, which would confuse you if you didn't watch the presentation first and wonder why I went with B first, then A. But let's just stick with it, and we'll go from here. Okay, so we have the second array down here, A, which is initialized to 8 by 10. I want to make a math, multiply grid. So where you have the columns and the rows, and where, let's say for instance, we have, I'll just draw it out here on the screen. We have this 10 by 8 grid. We have 10 columns and 8 rows. Okay, so that's our 8 rows. Here's our 10 columns. And I just want to make the math table out of this, the multiplication table. So 0 times 0 would be 0. This is going to be 0 throughout the entire thing. And we're going to see a similar pattern here at the beginning of each row. And rather than fill in the whole thing, let's just pick a value. Let's say we wanted to do 3 times 5. So we'd go to this part of the grid. 3 times 5 is 15. And 15 would be there. If we did 7 times 2, that would be 14. So you would fill in all the other values yourself normally. Well, how can we do this automatically into our 8 by 10 array here? Again, we can use for loops. For loops and arrays go hand in hand. So we'll go ahead and we'll do nested for loops to populate this particular array. First, we need to specify if we're going to do the rows as the outer array or the columns as the outer array. For me, I tend to remember better if I make the row the outer array. but it is really entirely up to you which you decide to use. And to make it easier to remember what I'm doing, I'll actually name the variable row instead of something like r. So we'll say for row equals 0, row is less than, of course, I could specify 8 and then plus plus row. But I really am not a fan of putting hard-coded values like this 8 in here. So rather than use that, I'm going to use knowledge I have about A and call one of its methods to replace this 8. So I could say A dot, and I want to say it's less than the length at a given dimension. So I'll use getLength. And we know row is the first dimension, but arrays are 0-based, so I don't pass it a 1, I pass it a 0. Now, this will return an 8. So I will loop from 0 through 7. When it hits 8, in other words, when this plus plus row makes row an 8, then this loop will quit. But for each row, I have 10 columns I need to assign to. So inside of this loop, I need to have yet another loop to represent each of the columns for each of the rows. So I'll say for int col for column equals 0. Column is less than, I'm just going to copy this. And if you guessed I have to change the 0 to a 1, you're absolutely correct. Then plus plus column. So now inside of this inner for loop, I have to populate my array, the A, with values. We know to access an element in a two-dimensional array, we have to specify row, then column. The good news is, because I have very well-named variables in this example, that's going to be trivial. It's A, row, comma, column. What do I assign it to? Well, since we're doing a math table, we know that the value stored at each cell in this grid is going to be the row value times the column value. And that intersection there is the result. So I just have to say row times column. This is all well and good, but it would be helpful if we could print this array out. So I'm going to create a method called printArray, and I will pass to it a two-dimensional array. I'll just call it A. And I'm going to use a very similar technique to access each of the elements in this array. Rather than trying to figure out using a complex math formula where a particular element is in memory, I pretty much have to take this loop and instead of doing a write to the location, I need to do a read essentially, which means I'm going to have this A row comma column on the other side of an equal sign. Instead of on the left-hand side, it's going to represent an R value in this case. But I can do that without actually using an equal sign. I could just say console.write, because I know I'm going to put it out to the console window. And here's that value. Well, this would be good enough to print out all the values. The problem is the spacing is going to look horrible, and everything is just going to run on from left to right off the screen to the next row or next row of text on the console window. So we have to put a little formatting in here. We know the largest value we're going to have is the one represented by 7 times 9, which last time I checked is 63. So we know the biggest value we're going to have in this grid is 2 digits long. The good news is when I write values to the console window, it allows me to do something known as string formatting. Now this is a little advanced for this particular topic here, but I am going to tell this console write command to format these values it's printing as 2 characters. And if the first character is blank, it'll inject either I can specify a 0 or a space to take its place. So we know, for instance, all these zeros are only going to be 1 character. But later on, we have a lot that are going to be 2 characters. So we need a way to make sure they line up. So I'm going to use traditional string formatting for this and specify that each value is going to be, this is 0 by the way, represents the first parameter in the list here that I'm passing to console WriteLine. The comma 2 is going to specify write justification 2 characters, and it'll inject a space where when this is only a single character value, like for 1, 2, 3, 4, 5, etc. As soon as it gets to 10, then it doesn't inject a space in front. And then I'm going to put a space afterwards. I can even put 2, I think it'll look cleaner, to give, again, better formatting to separate the numbers in one row. Still not done. After I'm done printing out all of the values for one particular row, so I've looped through all the columns for this row, I have to instruct the console to write the next value on the next line. If I don't have this, it'll continue writing off the values to the right. So then I can take print array and pass A as such. And we'll hit run. And here's our times table. Unlike one-dimensional arrays, there is no simple method like array.resize to resize a two-dimensional array quickly. The problem here is if you were to specify only one of the dimensions, like you want to add several rows, that in itself wouldn't be too complicated. But if I needed to add multiple columns, then things get a little more complicated. So here you would have to take this approach manually and create a new array for the size that you wish your new array to be. So if we wanted to, we could say int, and then it's going to be a two-dimensional array again, a2 is equal to new int, and we're going to specify, here we had 8 by 10, let's say we wanted this to become a square. So we have a 10 by 10 grid for our multiplication tables. We would again have to do a memory copy. Using array.copy, we specify the source array is A, the destination is A2, and we're going to copy length number of values. Did the red flag pop up for you yet? Because what are we doing here? We don't have two dimensions defined. We're specifying length as a single value. Remember, in memory, a two-dimensional array is a contiguous chunk of memory. It is linear. So what we're going to do is copy what is already in the source array into the new location, and since there are 2 extra rows here, the last 2 rows are simply going to be zeros. That's the default value for ints. If we wanted to resize the columns as well, this technique will not work. This technique only works when we're trying to change the number of rows. If you have to change the number of columns, you will have to step through the array and copy one row at a time, taking into account where the gaps are. So, not an easy technique at all. However, this is not so bad because we're only dealing with a single command, and as long as we're changing just rows, we're fine. But then we also have to assign the new values to A2 for those 2 rows that are missing. So I'm going to specify A2 for each of the values for that set of for loops I just copied. but I have to change the starting position for row. It doesn't hurt anything to run the whole thing again. It's just we already have those first 8 rows worth of values, so there's no reason to start over again. So we actually do want to start on row index 8 because we already have 0 through 7. Then if we print the array again, and just for good measure, I'm going to put a console write line before the next print array so they don't run into each other. Then I'll change this to A2 to make sure I'm actually printing the correct array and click Start. And now you can see we have 0 through 9, 0 through 9, and 81 here is the largest value. I realize that the first row and the first column are awfully boring, and that's because we are using a zero-based array, but you could rewrite the code so that this 1 could be shifted up and to the left into the top position, and then we could actually have this array extend out to where the last value would be 100. Now that would be an interesting exercise for you to take on your own to see if you could figure out the appropriate technique without cheating. Using the same 10 by 10 array, have it so the values contained within the array skip the 0 row and the 0 column in the multiplication table, because everyone pretty much knows 0 times anything is 0, and it's a waste of space.